recording now. So we're going to do the very first differential equation. The very first one is y double prime plus y prime minus 12y equals 0 is a differential equation. And the first thing you do is write what I call the auxiliary equation. In S. You remember the S?
Yes, sir.
S is really an operator, and this is not even in the book. Okay, but I think it's a very interesting differential equation because it shows that a linear differential equation, all the solutions are exponential functions. Okay? Now, for the y double prime, you write S squared. For the y prime, you write S. And for the y, you just put 1. So we get minus 12 equals 0. And we want to solve for S. Find the zeros of this. It's just like in pre-calculus when you had, if you had x squared plus x minus 12 equals 0, you want to find the zeros. If they're real zeros, you can put them in your calculator and see it in the calculator. If you can factor it, though, you can find the zeros, okay, the real zeros. This particular one, you get S plus 4.
S minus 3.
S minus 3.
Yes,
in
sir.
fact, your voice will be on the video. Just if you got a question, you ask it, okay?
Yes, sir.
See, that's equal to 0. Now, this is pretty simple. So the solution is S equal minus 4 and S equal 3. So we know that the solution to this differential equation is y equal a constant C1. We just call that times e to the minus 4t. And then that corresponds to this one. And then let me erase this right there. Erase that. Now do it again. And then I add the 1 C2 e to the 3t. And this is a solution. Okay?
Yes, sir.
Pretty straightforward. It's a pretty remarkable result because you could find the C1 and C2 if somebody told you what the initial value of y was and what the initial value of the first derivative was. That's all you would have to know.
Yes, sir.
And you could plug that in and find out what C1 and C2 are. Anyway, this is the solution for the first problem. Now, I'm just going to next page, and we're going to try to do the second problem, which is
Y triple prime.
yes, number 2, y triple prime minus. So you can see some of the problems with this thing. It's not marking the way I would really like it to do. Y triple prime minus 4 y prime equals 0. So for the y triple prime, the auxiliary equation is s cubed minus 4s
Equals 0.
equals 0. So this we can factor out in s and get s squared minus 4, which can be further factored into s plus 2, s minus 2 equals 0. So these solutions, you just write down s equals 0,
S equals 2 and S equals minus 2.
s equal minus 2, and s equal plus 2. So now we can just write down the solution to this, and y would be equal C1 e to the 0t. Now either 0t is going to be just 1, okay? We'll fix that in just a second. Plus C2 e to the minus 2t plus C3 e to the 2t.
Yes, sir.
And that's our solution, except this,
Has to change to
since
1.
e to the 0 is equal to 1, the answer is going to be y equals C1, just a constant, plus C2 e to the minus 2t plus C3 e to the minus 2t. And that's the complete solution. Now, let's go to the next page.
Yes, sir.
Okay.
There you go.
So we're on page 3. We'll see what kind of video this makes. It won't be too bad. You know, it's at least got some explanations. The third problem,
It's y triple prime
y triple prime
plus 4y double prime plus y prime minus 6y equals 0.
So notice that y triple prime doesn't look too good, but you can tell it's y triple prime. So the auxiliary equation would be s cubed minus 4s squared.
It'd be plus 4s squared.
Yes, plus 4s squared. Plus 4s squared
Plus 4s.
plus s
Yeah, plus s. Minus 6.
minus 6 equals 0. Now here you have a cubic equation, and here you would have to figure out what the zeros of this are. Now you could probably do it by hand by using the rational zero theorem and come up with some potential possible real roots. But what you can do is put in the calculator and solve for the roots. Now, I'm going to do this. I can't show the calculator on the screen. If I had the one in our room, I could do it. But I'm going to put x cubed in the calculator plus 4x squared plus x minus 6. Then I'm going to zoom to the standard window. And if we did this right, you should see the zeros. In fact, what you do see on the screen, and I'm doing this sort of crudely, as you see 3 zeros, and I didn't do this to scale, but this one is plus 1. This one is minus 2. And this one is -3. Okay? So we got S equal -3, S equal -2, and S equal +1. And if you didn't have a calculator, you could use long division to actually try some of these roots to prove that there are the roots, okay? But these are the roots because your calculator clearly shows it. So then we can just simply write down for -3, we'd write down C1 e to the -3t plus C2 e to the -2t plus C3 e to the t. And that's the solution. Now, yesterday I did mention that we know that sometimes the roots of a polynomial equation may not be all real. They could be complex.
Yes, sir.
When they're complex, that tends to give you a combination of exponential and sinusoidal sines and cosines. But we won't take that up, okay? But anyway, that's how you do those three problems we talked about. So now I can stop.